Alright, in this video I'm going to go over the load motor and the setup I've got. I'm not sure how accurate any of this stuff is at the moment because I need to just run more tests just on one ESC. This is just quickly going through each ESC. I say quickly, the video ends up being, I don't know, 20, I can't remember how long it is, but it's like over 20 minutes, probably a bit too long really. But hold out, I've left the vest at last, and that's just quite interesting, the end bit, about the you know, when you put some airflow on the vest, but yeah, it should be right. I think it's I think it'll hold out. I just need to, I'm printing a new sprocket for the load motor because yeah, that didn't hold out too well. It just kept spinning and the nuts like gone into the sprocket now because it's obviously spinning in the way that it tightens up, so it just tightened itself up into the sprocket. So I'm printing one 100% infill and see how it goes. Should be a lot better. Yeah, so this video, all the I don't know if the amps are correct. Like, it was only shown that it was one point the vest could only handle 14 amps, but then I tried it another day and I was getting like 23 amps, and I'm not sure. It was 29 degrees in the shed that day because I've been like running it a bit, so it got quite warm in here. The other day I done it. It was quite a cool day, so it, you know, it's probably 10 degrees cooler in the shed. So yeah, there's a lot of different things come into play. So yeah, take this as it is, and yeah, I will do some more videos showing just, you know, dedicated to the vest, dedicated to the red brick, and try and get that red brick starting good. And in future videos I'll try and keep the video pointing at the sprocket and gear so you can see the RPM, and you know, it's a bit boring not being able to see any of the actual workings of it turning. You're just looking at the side of the motor, but you know, this is just to show you what I've got here. Alright, cool. Hope you enjoyed the video. If you do, subscribe and like. Cheers. Basically here we're going to have amps, so this will be the phase amps. Phase amps here. Also I've got temperature, that's linked to the this linked to cooling fins on the red brick ESC. It's actually rated at 200 amp ESC. So we'll see if it's actually 200 amp, but I can't pull 200 amp. I can't produce 200 amp here, so, but we can give it a go. This is just your battery amps. One of the LCD bits is missing on this 0, so sometimes when you get 8 it looks like 0, 9 looks like, I don't know, like read 7 or something, I don't know. But yeah, anyway, you can sort of, I'll try and match the numbers so they don't interfere with the reading. So, you know, use a number that doesn't need that line. So at the moment I'm using this one as the drive, only because that one produces more load. This motor becomes more inefficient, so I can pull a lot more amps. Obviously the ESC needs to put out more amps to turn that because of that heavier load. So that's the way of stress testing these ESCs. If I was testing the motor, obviously I could just go the other way, but this way I've got a little fan on here. I'll just use that because I've tested it. I just want to get it back to room temperature before running the test. I would say it's quite a good way because you can test these alternators and see their overheating point, see how many amps they can actually handle before overheating. So with the load motor, I've got all the wiring coming out the back, coming down, and just made like a little coil that goes into like a delta configuration. I was trying to work out how to get the same amps across all phases, and it's really confusing me. I thought, well, wait a minute, I'll just make a delta configuration with a bit of wire, and that does heat up pretty hot. I had it on the floor and it got red hot. It was pretty damn hot. Now I think that's because of the lower resistance, I'd imagine. So lower resistance there, so that wire heats up before any of the other wires. These wires, the other wires don't get hot, and the alternator doesn't get hot. The only part of the alternator that does get hot is the field windings, which is pretty good. Another little one is that sprocket. So it's a 15 tooth sprocket I printed in nylon. There was another person who commented and made a video about it. He 3D printed a sprocket in his video, and I thought, oh well, I'm going to give that a go. I didn't even think it was a viable option, but it's holding out. It has slipped a few times. I'm going to reprint another one with a higher infill, just so you can clamp down a bit harder. So at the moment, because this infill is, it's like 25% or 30%, as you do the nut up, it wants to squish a bit. So with a heavier infill, or even 100% infill, I think that'll work really well, because the teeth are holding out. So the teeth are holding out, it's just the centre that's sort of dull in a bit. But yeah, I'll get RPMs as well. I don't know if they're really needed at this time. Obviously we're just trying to create some amps through these ESCs, but yeah. Sweet. Oh yeah, also one other thing I totally forgot is I've got the PWM controller, which I increase the field windings in the load motor, and that gives me a variable load, so I can actually start off, because the redbrick doesn't really like starting with a load. I start off with no load at all, start it, get it running, then increase the load, and yeah, it works pretty well. It works a really good way of changing load and increasing load. So anyway, I'll pause the video for now and then just cut back to it once I've got set up. Right, I'm going to start the load test. Like I said before, the big motor is the load, the small motor is the driving motor. I'm just going to find a steady kind of ampage, just see how hot it gets, and go from there really. It's just sort of basically just to show setup. I'm going to try and record some of the settings, but see how it goes. I haven't fully worked it out, how to record everything yet, but yep, let's give it a go. Alright, so the volts input is like 25 volts, 24 volts, so yeah, I can work the amps and stuff from there. So I'm going to just turn up the redbrick now. Then increase the load. What was happening there, the sprocket was flicking. It's over 20 amp. It's over 20 amp full. should do is find what it comfortably sits at to keep it 80 degrees. You know when you've reached your temperature limit when the heat shrink melts. So yeah, that was shit pretty toasty. Jesus. What I might do is just get a little fan on it quickly just to cool it down. Where is the fan? There it is. But yeah, I thought that was pretty good. So the load motor's not warm at all. Yeah, the driven motor like 103 degrees. I was wondering why it's getting so damn hot in this shed. Can you see that? Can you see that? No, it's gone. But anyway, yeah, that motor's got seriously hot. So what I do is I let everything cool down and run the test with the vest. I want to show you what happens with the vest when you apply temperature. Once you supply airflow, once it's hit its temperature limit. Yeah, that's it. Cheers. Right, I'm going to put the vest through its paces and yeah, show you what happens. Mainly what makes me think these are quite good is that when they cool down, when they overheat, what happens to the amps, and then when you apply cool air, like some air to the feds, how it increases the amps and stuff. It's pretty cool. So same again, 24 volts, battery voltage there, battery amps there, the temperature there. So I'm not sure whether I might just keep amps on there and then just use the gun to get the temperature, because it seems to go, they're pretty accurate against each other, so there's no point having this temperature. So I'll just put amps on here. I'll go to the 400 amp setting just in case we go over. I'm not sure if what the vest limit's set at. I suppose we can find out when we run it. So let's find out now. Let's plug in the field winding. So I've got 12 volts field winding straight to the driving alternator motor, and then I've got the variable PWM signal to the load motor, so I can increase the load. But yeah, here we go. That's the load applied, just lower it down. Probably try and get to around 30 or something, 30 amps. The sprocket slipped again there. I'm going to have to reprint another one. see what happens to the amps. So it shows having adequate cooling really helps these vests out. Blow on it. So yeah, imagine if you had cooling fins on there and everything, it would make quite a big difference. But it's under full load, so it's really struggling at the moment. I can decrease the load a bit. And then that'd pick up the RPMs, but the load should stay relatively the same. There it goes. And any slightest breeze changes the amps. So one little bit of air might melt on it. So motor's sitting there. Yeah, 60 odd. Can't quite see. 64. The vest is now sitting at 74. So yeah, she's definitely overheating. But yeah, I'm going to test each one as they come, each unit. So I try and put as much cooling on the vest as I can, and then that will give you representation of what they can actually run at if you cool them, versus trying to cool the red brick as well. The thing with the red brick is it'll just overheat and cut out. I think it gets to 100 degrees and cuts out. So, but yeah, this video makes some sort of sense. So one other thing I was going to do is going to show you the amps, the loaded amps, going back to the cooling. Going back to the water. So stay over here, might be a bit wobbly. There, hopefully that's good enough. So that's just one of the phases. There, hopefully you can see. Yeah, let us know if there's anything I can change for testing, or if we've got, if there's any other ideas out there that you can help me with. Happy to hear them, and yeah, go from there. Cheers.